Hello and welcome to another episode of Making Diablo clone in Lisp. So today I'm going to be doing more literate documentation to the whole project. So yeah, I'm still kinda not even halfway through, but probably like 10th way through. Is that a word? So yeah. This week has been hectic to say the least, because yeah, I got my fingers cut with a knife, well, accidentally, that is. And then yeah, I got a lot of work, so yeah, I haven't been touching a lot of this project, well, this week. So yeah, I've gotta like pick up where I left last time and just carry on. So yeah, let's see what we have here. So I think we gotta start with data tables today, and yeah, let me have a look. So what do I have here? Okay, so we got a config section ready, and then we got like file system, I guess. Wow, that's big. It's so big, put it out. Sorry. So yeah, where was I? The file system, and then the logging subsystem, which starts above here, and then I got this section about the actual main file. So I think I was going to move like in the order with the files with the subsystems of the engine, like in the order they appear in the main file. So there was like login file system and config. I think they all were like here in initialization or something. So let me see, yeah. So there was log, and then file system, then config, and then, well, the next thing to work on, it would appear that would be the data tables, right? So we got this tiny bit of code, and yeah, then we got this, which initializes the screen with some options from config. And then yeah, we got this inhibit file, screensaver, blah blah blah, event sources. Oh yeah, event sources. Probably I should start with events then. I'm not entirely sure. I mean, by the logic of the whole thing, like the data tables are loaded at the beginning, and yeah, probably I should start with those anyway. Because yeah, here we go, load data tables. So I guess only after that I would go with, yeah, and then so it looks like my plan was to continue with events after I document ECS stuff. So yeah, that probably makes sense too. Okay, so let's start with data tables then. So let me see the actual file here, and yeah, so I think we gotta have the, how it's called, this thing for tangling to be well, working. So let's just copy that, remove like that stuff, and then yeah, change the file name to datatables.lisp tables. Oops. Yeah, no app experts, blah blah blah. So yeah, here we go. So let's then start with, well, documenting that. Okay, so how do I start that? Yeah, I probably have a mild case of like fear of the empty, how do you call it? Fear of empty page or something. All right, so like the next step is data tables. Data tables, like the, which are the like databases. I mean, not exactly the databases, but like, which are the well, I mean, they're not like relational database or something, but they kinda are database in primordial sense. So probably I should just yeah, leave that yeah, next to the data tables, which are the databases where the game stores, where the engine the databases like looks for game specific data. Right, okay. I mean, right now, I think I only have like one, right? So let me see. In resources, oh, I don't have resources here, so let's go to game dev, data clone kit, resources. I can't see shit about my microphone. So yeah, resources, and yeah, my finger still hurts. So yeah, this is going to be awkward. Okay, so tables. Tables, it is here, demo CDB. So what do we have here between those sheets? We have impact sounds, and that's it, right? So let me see, can I? No, I can't really fold that. Okay, impact sounds, probably I could just do that and then undo. So the lines, yeah, only the impact sounds for now. But I mean, it's kind of designed to have all kinds of data later. So yeah, let's document that. The database looks for game-specific data. So the file format it uses for those databases is how they formulate that. So it's taken from CastleDB, like tool, which by the way is a bit, what's the word, deprecated or something, but whatever. So yeah, structured static data. CastleDB, structured static database is in collaboration. So the file format uses for the databases is the same as now. How they formulate that? The file format it uses for those databases like is taken from yeah, I think so, is taken, or maybe like compatible with the file format it uses for those databases is, yeah, let's put it like that, is compatible with CastleDB editor. Is it editor? Can I like use that? Is this word? Editor, map editor, yeah, sure. I already have that. The model allows the editor to validate the data. Looks like any spreadsheet editor, except that sheet is a data model. Okay. Using CastleDB editor. Yeah, I think I can use the word editor. It's compatible, so let's have a link to that. Can we have HTTPS here, please? Nope. I mean, why though? Yeah, weird. So anyway, CastleDB editor. And I also should mention that basically it is just JSON. So the file format used for those databases is compatible with CastleDB editor, and basically is a JSON with predefined model. I think I also have to use truncate lines. Right, the predefined model. Oh god, this is painful. Okay, so a JSON it is. So what do I have in this file? Yeah, right. So I also should formulate that the data read from those databases is okay. Now, god damn it. Okay, I'll get back browser later. So where was I? Yeah, data tables, global data tables, read hash table. Yeah, right. Well, data table, blah blah blah. So the thing is, I make a kind of how do I put it? A kind of a index, a database index, to like make reading this data easier. Right. So how do I put that? I mean, it's not a big file either. So, well, I'll probably finish with that on today's stream. So, the indices, right? How do I use that? Table indices. So build data tables. Look with indices, blah blah blah. Table indices with indices. Get f indices. Set get hash build data table. Ooh. Index. Oh yeah, okay. So we get index columns and value columns. Alright then. So I think, yeah, I remember my specification for this crap. So those two fields, like armor class and weapon class, they constitute a compound index, well, in terms of relational databases. And then sound is, well, all the data that's left, right? And it's kind of denormalized. I'm not sure I can use that term here. Okay, let's just try and document that. So the data read from those databases is stored. No, how they is built. Is that the word? Is built? No. So the data read is organized. Is organized in the way that allows for like quick access, or what would be the word here? Not the access, but the fast. Well, yeah, the fast access. Organized in a way that allows for fast access using predefined index. Fast access using. No, not that. I mean, what? Where is the actual access to the table values here? Yeah, right here. So table value ref. Table designator predicates. So what is predicate? plist references the data. Blah blah blah. Returning even the column value, single column, a plist, multiple or default if no row corresponding to predicate is found. Column. Specify the column to return. In the second case, the function assumes the column names predicates are alphabetically sorted. Oh, that's also something to, well, document. Right, so how do I put this sentence I just started? Is organized in a way that allows for fast access using, I mean, not using, but with, or like, so the thing is, I kind of have to supply those index columns in order to get this value. So to get some sound, I have to supply both armor class and weapon class. So how do I formulate that, goddammit? It's organized the way that allows for fast access. I mean, it's not even... The point is not even in fast access. The point is that it is like the only way to access this data. It allows for fast, like row, like fast row access. Using using index columns, index column values. Not like index columns, using index columns, which are also predefined, Okay, does this make any sense? The data read from those databases is organized in a way that allows for fast row access using index columns, which are also predefined, like for every table. For every table. Okay, so let's just render that. I forgot the key button again. Ctrl-C, Ctrl-E, H. Yeah, okay. And let's just have the browser, shall we? So file, yeah. Ooh, that's some aggressive music. Yeah, data tables. Next up is data tables, which are databases where the engine looks for game-specific data. The file format it uses for those databases, I mean not for, but for like storing, or how do I put that? The file format, the file format it uses like to store those databases. Yeah, I think that would be correct. So right, next up is data tables, which are databases where the engine looks for game-specific data. The file format it uses to store those databases is compatible with CastleDB editor, and basically is a JSON with predefined model. The data read from those databases is organized in a way that allows for fast row access using index columns, which are also predefined for every table. Okay, so I think it's time to dive into the code. So let's start with that. Okay, so begin src, and then I also probably want a name, right? Why the highlighting is weird? Maybe I should how do I revert buffer? The fuck? Okay, that works. So right, the name would be, how do I specify the name again? Yeah, like that. Okay. So the name obviously would be, what would that be? Like global data tables. Global data tables. Okay. So then let's reference it here. Global data tables. Okay, cool. So right. So it is stored in, I mean the data I was talking in previous sentence, right? So like the data from the database is organized in a way that allows for faster access using index columns, blah 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 blah. It is stored in, yeah, probably not a good way to start in sentence. So the like database data, I mean it sounds a bit well, not right. Let's put it like the data, I mean that's the second sentence that starts with the data. God damn it. Right, so probably like this data. This data is stored in global variable. Yeah, let's have it like that. So I forgot, yeah, tilde. So data tables, which is a hash table keyed by the table name, keyed by like the keyword. Where do I add this word? Keyed by the, like the keywords representing table names. Okay, got it. So let's export that and have a look. All right, we got it. So this table is starting on global variable data tables, which is hash table keyed by the keywords representing table names. Okay, good. So what would be next? So the next is this function build data table and then table indices. Yeah, probably I should go in different order. Build data tables. So this one calls that one, right? Yeah, it does. Dun, 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 dun. I mean, why would I even put that here? This function probably does not require... Yeah, it does not require shit. So probably I could have put that above. Whatever. So let's just, yeah, proceed to the next bit, which is those specifications of, well, indexes. So I'm not sure about the name yet, so let's have it. LISP, and LISP, we got it. Wow, this is weird. I mean, why the syntax highlighting is fucked up every time I paste something? This is weird. Okay, so table indices. Let's have it here. Table indices. I mean, I would have some more code here. Right, table indices. So next, there's a global constant called table indices, which stores the specifications of tables of tables known to the engine. Right, so it's also important to mention the order, right? And well, the actual format. Wait a second. Oh, so it is like a plist. Okay. So table indices is a plist in which key names reference the table names. No, in which keys reference the table name, and values are the lists specifying. I mean, how do I spell that? God damn it, specifying. Yeah, I fucked up with the spelling. Specifying. That's right. Yeah. Okay, so are the lists specifying the columns? Namely, it is. I mean, should that be like a proper list or something? So what do I have here? Append table indices, so we got it in variable indices here, so then getF designator, so we got index columns. Wait, what? Index column, how they, I mean, what's going on here? Oh yeah, it destructures the list, right? That's nice. But I mean, how does it work if I destructure it like that and it has, like, for instance, 3 elements? Okay, let's have a look. I'm interested. Oh, goddamn, yes. Probably I should have used Emacs, right? So let me switch to, yeah, I am already at the Lisp file, so I gotta start REPL. So if I have if I have a loop which has like 4, a couple of, yeah, some kind of destruction like that, like AB, and then I put here something like list 1, 2, 3, what would happen? So then for blah blah blah, like do, I don't know, print A, whatever. Oops. Yeah, break. So it kind of works. So what if I print B? 2. Okay. Okay, so it just loses the information, right? That's nice. I mean, no validation here, but still, I don't know. Probably I should have some kind of validation here. I don't know. Whatever. So let's get back to document and then, oops, no, wrong buffer. Right, so namely, the list specifying the console, namely the first element in the list should be, oh, and by the way, should that be, oh yeah, that, I mean, it looks like it should be list, right? So let's have a look, index columns and value columns. Index columns, indices mapcan, yeah, I'm using a mapcan here, so it should be list, and then value columns, also mapcan, also list. Okay, so the first element in that list should be another list, a list consisting of, No, sorry, I think I'm misusing English again. It should be another list that can... No, sorry. Another list consisting of... consisting of the... like... of the column names. Should be another list consisting of the column names. In alphabetical order. Yeah, probably I should make it bold. Like that. The second list. No, like the second element should be also a list containing like all of the other columns. Containing, I mean, is that grammatically correct? Containing all of the other columns. Containing all the other columns, I guess. Yeah, right. The second element should be also a list containing all the other columns. Okay, let's have a look at, well, how that looks. Oh, what the fuck? I think I messed up something here. Begin SRC. Oh yeah, and SRC LISP, sure. Yeah, okay. So next there's a global constant called table indices, which stores the specifications of tables known to the engine. Table indices is a plist in which keys reference the table name and values are the lists specifying the columns. Namely, the first element in that list should be another list consisting of the column names in the index. Oh, I missed that. Should be another list consisting of the index column names in alphabetical order. Right. Consisting of the... Wait, what? Yeah, index column names in alphabetical order. The second element should be also a list containing all the other columns. Yep, pretty much that's it. Okay, so what's next then? Next there are a bunch of functions which load all of the stuff, right? Data tables, blah blah blah, table, and then the accessors, table value ref, and table value ref with a star, which does what? Single column. Oh yeah. Am I using it anywhere? Anyway, table value ref. So like with a star. Oh yeah, no wait. I actually don't. The table, so it is just... Yeah. Just a safe version to be sure. Alright, okay. Where was I? So let's start with describing all of those things. Wait a second, I just remembered that I also have a file called castledb.lisp, which also have this function, which I should document, but yeah, not a big deal. I'll probably just have it after this section. Load castledb tables, yeah, right, okay. So, where do I start then? With built-in functions, I guess. So let's start with this one. Okay, wait a sec. So have I added table indices? Yeah, I did. Alright, so build data tables. Wait a sec. Which function is the most top level? I think that would be like load data tables, right? Yeah, right. Okay. So let's start with that then. Data tables. So name, load data tables. Begin SRC. Yeah, damn it. Begin SRC LISP. And then end. Damn it. SRC. Okay. Something weird with syntax highlighting again. Okay, so load data tables it is. So, right, okay. So how do I start here? Load data tables. I think this one is called from dataclone.lisp, right? Load data. Yeah, here it is. I wonder why it's not working. Yeah, okay, it is working with Alt N and Alt P. Okay, or rather Meta N and Meta P. So the load data tables function called from. Where is it called from again? Load data tables. We'll call this in the tail. Blah blah blah. Okay. So it is called in. Wait a sec. Which function is that? I'm lost. What the fuck is going on here? So next, run engine. Oh, so that should be run engine, right? Yeah, right. Here it is started. Right, called from run engine. So what does it do? Oh, priorities. Yeah, I also have those priorities. Wow. Okay, so called from run engine just enumerates the like tables subdirectory in resources, trying to find any files there with .cdb extension with the help of. So have I described enumerate directory already? I think I did. Enumerate directory, yeah. Right. The help of enumerate directory macro we've seen previously. Whoa. I mean, what the actual fuck? I just selected like an item from auto suggestion list and it deleted a bunch of text below. I mean, Emacs, what the fuck? Previously, no, I wouldn't. Okay, now we've seen previously. So what does it do then? Make instance character stream. Yeah, so after that, load castle db tables. So wait a sec, where does that come from? Load castle db tables. Oh yeah, I think that's the one from a separate file. Load castle db tables, multiple binds. All right. So next it uses load castle db tables function we'll describe in the next section to load, or like, what is the word here? Decipher? I mean, from the JSON. Serialize. What's the antonym of serialize? I'm not sure. Antonym of serialize. Deserialize. Wow, that makes sense. Thanks, man. Deserialize. So we'll function will describe in the next section to. Yeah, right. Okay. How do I spell it again? Deserialize. I think that's right. Yeah, that's right. Okay, so the next section to deserialize the data from the JSON. Okay. And probably here I should add that it uses it along with a character stream instance. It uses function called with... Oh, wait a sec. Function will describe in the next section to initialize. Yeah, along with... Or like called with. Called. So next it uses blah 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 function will describe the next section called with the character stream instance to deserialize the data from the JSON. Okay, awesome. Right. So what happens after that? We have this loop which does what again? Get hash of priority system of priority. Okay. So I should also document that. Wait a sec. So where's this table indices go to? Oh. Weird, but okay. Build data tables. Alright, so this function obviously does this stuff with index. Call function blah blah blah, visualize the data from the JSON. After that, we have some awkward loop to figure out the priorities in case. So I have to remember how, I mean, where is that put, this priorities. So game def, key resources, tables, demo. So yeah, props. This props is property of the sheet, right? Okay, so to figure out like file, or rather database file priorities. So like sheets. Okay, the singular like sheet object from aforementioned JSON. Could have custom property saved in props field called well, priority. Oh yeah, probably I would document that when I'm loading this, right? So let me just remove it from here and put a bit like here. And then I will have this section like, no wait, 2 stars? Yeah, 2 stars. Castle DB, like support, or how do I put it? Castle DB format support. Yeah, just as I had with ASC Pride. Okay, Castle DB format support, blah blah blah, yeah, whatever. So after that we have some awkward loop to figure out database file priorities. So refer to how they reference that Castle DB format support. So refer to Castle DB format support for details. To figure out the database file properties. So what is going on next? Data tables, all tables, table indices. All right. So finally, this function calls build data tables to. So wait a sec. Does it load like all of the data? Yeah, I think so. Because we enumerate directory and we put all of the stuff inside all tables, right? So, right. Finally, this function calls build data tables with all of the gathered data. And table indices specification, and like custom table indices specification, it was supplied within table indices argument. Table indices, god, my English is terrible. Table indices argument. Right, so let me just reread that. Finally, this function calls build data tables with all the gathered data and custom table indices specification. It was supplied with in table indices argument. Yeah, that pretty much makes sense. Alright, so finally it calls blah blah blah. Okay, so let's move to that function then. Build data tables. Alright, so let's close that and yeah, build data tables. So name would be obviously build data tables, and then let's do begin src, damn it, src LISP, and then end src. Okay, alright. So, build data tables. So the build data tables function takes care of actually, no, how do I put that? Takes care of building the indices, or like takes care of organizing the data according to the indices we've discussed previously. Wait, have we discussed that indices stuff? Yeah, so we got global constant table indices, specification of tables. No table indices per list, blah blah blah. Yeah, we not exactly discussed that. According to the indices. The indices specifications. Or like index, no, indices, it's plural. So yeah, function takes care of organizing the data according to the table, to the indices specifications. Right. Builds data tables. Okay, so let me get back for a moment. With all gather data and custom data specifications was applied. Argument. So the result, the final result, is stored in data tables variable we've seen before. Alright, so the build data tables function takes care of organizing blah 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 in the specifications. Okay, let me just have a look at the result in HTML. Okay, where was I? Ooh. Right, so blah blah blah, alphabetical order. Alright, so load data tables function called from run engine just enumerates the tables subdirectory in resources. Trying to find any files there. It doesn't sound exactly like English, if you catch my drift. Trying to find any files there. Yeah, whatever, I'm not a native speaker anyway. Right, so with cdb extension, with the help of a enumerator directory macro we've seen previously. Next, it uses load castledb tables function we'll describe in the next section, called to the character stream instance to deserialize the data from the JSON. After that, we have some awkward loop to figure out database file priorities, refer to 2.7 for details, which obviously is the next section. Finally, this function calls build data tables with all of the gathered data and custom table indices specification. It was supplied within table indices. What the fuck is that? Table indices. Okay. All right. Where was I? Specification. It was applied within table indices argument. The final result is stored in data tables variable we've seen before. Okay, good. So the build data tables function takes care of organizing the data according to the indices specifications, or like rather the specification it was given. According to the indices specification, it was given. Okay, so what does it do? First, it tries to merge that table indices specifications with like global table indices. Indices constant we've discussed previously. Right. So what is going on next? The result make hash for count of type fixed num from 0 designated new hash key using hash values of so it basically just goes over all of the tables, right? Okay, so first it tries to merge blah blah blah. Next it just iterates over all of the tables it was given. Like since data argument is just a hash table with like table names as keys, goddammit, keys, and like lists of data, like lists of rows, let's put it like that, and lists of rows as values. So it iterates over all the tables it was given and just feeds the row data, right? It is row data. Am I right? Table, index, columns, columns, so table. What is table for row? Yeah, it is. Okay, so just feeds the row data to build data table function, which does the job of organizing the data for a single table. This all does not sound very nice. Okay, maybe let's just have a look at HTML then. Right, so build data tables function takes care of organizing the data according to the indices specification it was given. First it tries to merge that table indices specifications with global table indices constant we've discussed previously. Next, it just iterates over all of the tables it was given, since data argument is just a hash table with table names as keys and lists of rows as values, and just feeds the row data to build data table function, which does the job of organizing the data for a single table. Okay, alright, I think that will do. So result is make hash, yeah, okay, right. So then it is the time to copy that function, build data table singular. So where is that? Build data table singular. Here we go. Okay, my syntax highlighting is fucked up again. What the fuck? Whatever. So what does it do? No, it just makes me fret. Okay. Buffer. God damn it. Okay, so build data table. So what does it do? For row table indices map can list column for row column. It probably is a list, right? Table lists of rows as values. Okay. So map can index columns. Right, list so it gets values of those index columns, right? And then for values equal if length 1 columns get a row columns else map can, so it goes over value columns and again takes this from a list and then feeds it to map can, which makes a list, right? Okay, so then set I've got hash. Okay, so build data table function. So how do I put that? Transforms. It transforms the rows represented asplists into hash tables in which the keys are the lists. Wait a sec. I mean, is it always a case? Is the index values always a list? Get hash indices result indices. And indices is a result of map can, which is indeed a list. So like if I have a single column as the index, it would also work, but probably it would do some extra, I don't know, some extra constant, because it would have to take a hash value of a list instead of hash value of some singular atom, integer or string or whatever. So yeah, probably I should also make a separate case for that. I'm not sure. I mean, should I? Right now I only have one table known to the engine, which is, well, this sounds, impact sounds, and it indeed has a compound index of 2 columns. So, well, probably I shouldn't bother right now, but in future, yeah, probably I would get back to that. But yeah, let's just return to this sentence, shall we? The function transforms the rows represented by list into hash tables, in which the keys are the lists of index columns values, right? The lists of index columns values. And the values are either singular values, god damn it, singular values, or lists of all of the other column values. I hope it makes like a tiniest bit of sense. Okay. So single table. So build data table function transforms the rows represented asplists into hash tables, in which the keys are the lists of index columns values, and the values are either singular values. I mean, I probably used the word values too much in this sentence. but whatever. So the values are either singular values or a lists of all the other column values. So probably I should demonstrate that with an example. For that I would have to quick load the engine, and yeah, I'd probably just start the new Emacs. So yeah, a bit awkward to show all of my stuff here, but yeah, so where was I? Yeah, I should open that again. Products, game dev, debug kit. What should I open? SRC, something from that. Whatever, data tables. Okay, so then start the REPL and load the stuff. Yeah. Alright, and it would take a little while to load, and yeah, here we go. So first I probably should load the thing and then just have a look. Oh, what the heck is that? I probably have some extra spare print somewhere which I should remove, but whatever. FS. Yeah, I do have a print here. Alright, so what was I trying to do? Right, so I was trying to demonstrate those tables. So let's have a look. Data tables. Yeah, that's a hash table. So get hash. So what is the second? Yeah, and what would be the name? Like impact sounds, I believe. Impact sounds. Yep. And then this is also a hash table, and I wanted to demonstrate its internals. So probably I should call like Alexandria, what was it called? Like plist hash table? No, reverse hash table to plist or something. Plist hash table plist. Yeah, this one. Here we go. I'm gonna close bones. Sorry. Wait a sec. I'm not quite following how that works. I'm gonna close bone. Okay, so wait a sec. Where is that specification? Yeah, here we go. Armor class, weapon class, and then we have a sound. Armor class, bone. Wait a second. So this is not a list. This is a playlist, right? Wait, I'm just not getting how my code is working. What if I call hash table a list? Would that make sense? Class. Oh yeah, here we go. Swordbone 1, Swordbone 2, Swordbone 3. Armor class, kitten weapon class. So it is, I mean, the keys are playlists, right? That's what I missed. But still, I can't see. Oh, okay. Swordbone. Yes, I will copy just a little bit of that. So just this, right? Or I don't know. Fists. Whatever, a couple of examples would be more than enough, or just like 3, I don't know. Fists. Okay. So let's close that perhaps and get back to documentation. So then begin example, I guess. Begin. Why in lowercase though? And right now, yeah, okay, awesome. Nope, thank you very much. Okay, I wanted just that. Okay, and then end example. Again, why lowercase? So something wrong with syntax highlighting again. What the fuck? Do I have to revert buffer like every time to fix that? This is getting frustrating. Alright, so the example. Hash table plist, get hash, impact sounds, data tables. Right, so well, let's just pretend. I mean, if I open this CastleDB file, the thing is that I have some like give me a moment, tables demo. So the thing is, I have here like real lists, real Lisp lists, and this is done by like deciphering that with a Lisp reader. So the thing is, I mean, to have this example simpler, I would just like have a singular items there. Just pretend they're singular there to make it easier to understand. So yeah, let's just remove all that and probably that too. So wait a sec, it was a keyword, right? It should be a keyword. Okay, so then this like armory class, bone, weapon class, dagger. So then we have dagger bone. Sorry. So then bone have a class fists. Yeah, fists bone. And then some else. So to demonstrate, right, let's have a look into like impact sounds table that's embedded. I'm not sure I'm spelling that correctly. Embedded into. I mean, is that the word to use here? Let's have a look into impact sounds table. That's embedded into the engine. Yeah, I guess so. Embedded. Right, with 2D. It's embedded into the engine. Have a look into impact sounds table contents. Or like, let's have a look into contents of impact sounds table that's embedded into the engine. So yeah, this is also a lists, which is a surprise. So getf list column. Oh yeah, list column, and yeah, well, that makes a plist. And by the way, this does too, right? Okay, so let's reformulate. So this function transforms the rows represented as plist into hash tables, in which the keys are the like the p-lists of index columns, and the values are either singular values or p-lists of all of the other column values. The p-list of all of the other columns. Yeah, that's better. I mean, now the word values is used much more rarely in this sentence. So to demonstrate, let's have a look into contents of impact sounds table that's embedded into the engine. Okay. Right. So then just this function goes here. All right, let's have a look at that. So I probably don't need that, and maybe that too. Right? Yeah, I'll leave that at another workspace. Okay, so build data table function transforms the rows represented as p-lists into hash tables, in which the keys are the... Wait a second, are those... Wait a second, so I should reformulate that too. This function transforms the rows, the list of rows represented as p-lists, into single hash table, right? It is a single hash table. Yeah, it is. In the single hash table. Okay. Let's have a look. So, build at a table function transforms the list of rows represented asplists into a single hash table in which the keys are the plists of index columns and the values are either singular values or plists of all the other columns. To demonstrate, let's have a look into is that how people talk? Let's have a look into... I'm not sure I'm using that correctly. Let's have a look at... Alright, let's have a look. What if I'm using it without it? Let's have a look at. Yeah, probably the word here is at. The values of either blah 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 blah. Let's... Okay, to demonstrate, let's have a look at the contents. Okay. Alright. So to demonstrate, let's have a look at the contents of impact sounds table that's embedded into the engine. So let's see, hash table plist, get hash. Yeah, probably I should also do that. So let me switch to REPL. Or like, should I really? Yeah, whatever, let's leave it be. So hash table plist, get hash impact sounds, data tables. So we got that. Armor class bone, weapon class sword. I have sword bone. Armor class bone, weapon class dagger. We have dagger bone, blah blah blah. Okay. So then goes this function. Build data table. Dun, 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 dun. Alright. Probably I should add something here about the index and the hash table. So since we use index column values as keys in the resulting hash table, it should be obvious that the index column values should be unique, as it always is in relational databases. Alright, it should be that the index column values should be unique, as it always is in relational databases. Okay, good. Yeah, and by the way, I don't even have any kind of validation against that. So if it happens, it would just silently overwrite the value, right? With this setf. Huh. Yeah, okay, I would also probably need to think about that. Right, so since blah blah blah, okay. Let's have a look at this in HTML. Right, so since we use index column values as keys in the resulting hash table, it should be obvious that the index column values should be unique, as it always is in relational databases. Sorry, as it always is. Index column values should be, yeah, whatever. Right, so I think the only two functions left are those table value ref. Right. So finally we have a couple of, and this is not an accessor, right? It just gets the value because the table is read-only. Right. I have a couple of accessors of this, or like of a couple of accessors for the table data, for the data table data. Yeah, that would be awkward. Right, they are not accessors per se, rather they're the getters, since the table data is read only once it is loaded. All right. So the first one would be table value ref. Name the table value ref. This. Okay, the syntax highlighting is fucked up again. Thank you, Emacs. Right, so what does it do? Right, so this function, so the first one, table value ref, just accesses the hash tables described above. Just access the tables, the data tables hash table described above. It takes table designator as argument as a keyword, and so predicates by plist and plist of predicates which relate to. So wait a sec, it also should return a single column, right? Row get hash predicates. Yeah, right. And the list of predicates which relate to, well, to and list of predicates which relate to index column. So, right. So column if it specifies the column to return. List of columns if there are multiple. It can return default value instead, like specified. It can return specified default value instead of null, and it can return only a single column instead of plist when supplied with oops, what have I pressed? Wow, how did that was really awkward, and I had a tiny heart attack, I think, just now. Alright, so it can single column instead of plist when supplied with column. With a column keyword argument. Keyword argument. Instead of full plist. Let's put it like that. So yeah, there's not much to tell about it on this function, except the case that the predicates should be alphabetically sorted. Yeah, right, the column names and predicates are alphabetically sorted. The important detail of the, how do I call it, the protocol, the I forgot the term, the contract programming. So the contract, the important detail of the contract for this function is that the supplied, is that the supplied predicate? Why the is that supplied predicates plist should be alphabetically sorted by the names of the columns. Since this is how they are stored in the hash tables we've discussed above. So if we change the order, the hash value of the list would change, and this function wouldn't be able to find anything. Wouldn't be able to find the requested row. So what would be the verb here? To alleviate, I guess so. Alleviate, right? To alleviate that, there's a star version of this function, table value ref with a star, that does the sorting, does the predicate, predicates list sorting, does the predicates list sorting, in, how do I put that, in expense? Yeah, I should translate that from Russian. God damn it. At the cost, yeah, and the cost of, at the cost of slight performance penalty. Probably I could have that as a macro, but then again, if it would only work if the list is constant and like known at the compilation time, at which point I could just manually sort it. So yeah, I need this as a function. So right, that does the predicate sorting at the cost of slight performance penalty. So let's have it too. So I'm interested if I can have the name with a star like that. Let's test it. Okay. So that is basically it for this file. Now let's have a look at HTML first. Oops. Okay, so since we're using index column values as keys and resulting hash table should be always, the index column values should be unique as always in relational databases. So finally we have a couple of accessors for the table data. They are not accessors per se, rather the getters, since the table data is read-only once it is loaded. So the first one, table value ref, just accesses the data table's hash table described above. It takes table designator argument as the keyword and plist of predicates, which relate to index columns. It can return specified default value instead of nil. Sorry, I should reformulate that. Instead of nil, where was that? Instead of nil, when the column is not found. Right. Okay, so it can return specified default value instead of nil, right? So it can return specified default value instead of nil when the column is not found. And it can return only a single column instead of full plist when supplied with column keyword argument. Single column value probably. single column value. Okay, single column value instead of full plist when supplied with column keyword argument. Alright, so the important detail of the contract for this function is that supplied predicates plist should be alphabetically sorted by the names of the columns, since this is how they are stored in the hash tables we discussed above. If we change the order, the hash value of the list would change and this function wouldn't be able to find the requested row. To alleviate that, there is a star version of this function, table value ref star, that does the predicates list sorting at the cost of slight performance penalty. Okay, cool. So, yeah, right, let's move to tangling then. Where was I? So global data tables, then what do we have then? Then we have build data table. Build data table. Oops. Then we have table indices, yeah, those ones. Then build data tables plural. Then load data tables. And then table value ref and table value ref with a star. Table value ref. And then the one with the star. Would that work? I'm really interested. Okay, so I've compiled that into HTML. Okay, let's try tangling then. At this point, it would probably take quite a while, but in the end, it should work. Let's just open a terminal and switch to that. So yeah, I should go that. TMP, data column kit. Alright, so, groovy. Okay, I think it worked now, so let's have a look. So right now, we should have a file doc.lisp. Wait, why those are in green? That's because they have X bit. Why would they have oh, they have an X bit because I've set it. Okay, stupid. So the file would be, wait, which would that be? Datatables.lisp. So I should diff that datatables.lisp with the one from source, datatables.lisp. Alright, let's have a look. So first the GPL preamble, and then here we go. So yeah, identical. Okay, awesome, amazing. So I'm done with this data tables file. Yet another file. Yay, let's commit that. Okay, so I shouldn't commit that, but I should commit this. Yeah, probably I should have a quick reread through that. Because of the D format stoppers. Right, let's read that again, shall we? So yeah, data tables. Next up is data tables, which are the databases where the engine looks for game-specific data. The file format it uses to store those databases is compatible with CastleDB editor and basically is a JSON with predefined model. Probably, yeah, I should add the word just, I'm not sure. And basically is a JSON, whatever. So the data read from those databases is organized in a way that allows for fast row access using index columns, which are also predefined for every table. This data is stored in global variable data tables, which is a hash table keyed by the keywords representing table names. Next, there is a global constant called table indices, which stores the specifications of tables known to the engine. So table indices is a plist in which keys reference the table name and values are the lists specifying the columns. Wait, I've lost train of thought for a bit. Table indices is a plist in which keys reference the table name and values are the lists specifying the columns. Namely, the first element in that list keys, reference, the table name, the values. Okay, so namely the first element in that list should be another list consisting of the index column names in alphabetical order. Another list consisting of the index column names in alphabetical order. The second element should be also a list containing all of the other columns. The load_data_tables function called from run engine just enumerates the table subdirectory in resources, trying to find any files there with cdb extension with the help of enumerate directories macro we've seen previously. Next, it uses load_castle_db_tables function we'll describe in next section, called with the character stream instance to deserialize the data from the JSON. After that, we have some awkward loop to figure out the database file priorities, refer to 2.7 for details. Finally, this function calls build data tables with all of the gathered data and custom table indices. Specification it was supplied with in table indices argument. Yeah, right. The final result is stored in data tables variable we've seen before. Alright, so the build data tables function takes care of organizing the data according to the indices specification it was given. First, it tries to merge that table indices specifications with global table indices, constant we've discussed previously. Next, it just iterates over all of the tables it was given, since data argument is just a hash table with table names and keys as keys and lists of rows as values. At this point, I'm not sure. Probably they are p-lists, right? Let's have a look. So hash table, the data argument. Okay, data, data, column, blah blah blah. Designation hash key using hash value table of data. Right, using hash value table. So where do we have this table? Oh, we just pass it here. We just pass it to the letter table as the first argument, and this table, yeah, row in table, and this row is a p-list. Okay, I should change that. Where was I? Yeah, probably I also need to add the word just here, just as I thought. And basically is just a JSON. Alright, so go to this character stream, customer support, finally, blah 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 blah. I've lost that thing. Where was I? Oh yeah, since data argument. Since data argument is just a hash table with table names as keys and p-lists of rows as values. Okay, now we're talking. Alright. Next, it just iterates over all of the tables it was given, since data argument is just a hash table with table names as keys and p-lists of rows as values, and just feeds the row data to build data table function, which does the job of organizing the data for a single table. So then this build data table function transforms the list of rows represented as p-lists into a single hash table, in which, yeah, probably I should use that word without a space, right? Into a single hash table. I mean, do people use this as the single word? I'm not exactly sure. Table. I mean, if it is in code, most of the languages, including Lisp, does not allow spaces as the names of the identifiers, so this makes sense to type it in single word. But if you look like in Wikipedia, it is like in two words, hash table, right? Oh, and here it is used in a single word. Weird. Weird. That's weird. English is indeed weird. Alright. Where was I? Yeah, into a single hash table in which the keys are p-lists of index columns and the values are either singular values or lists of all the other columns. Wait a sec. Build data table function transforms the lists of rows represented as lists into a single hash table, in which the keys are the lists of index columns, and the values are either singular values or lists of all of the other columns. All the columns. Whatever. So to demonstrate, let's have a look at the contents of impact sounds table that's embedded into the engine. I mean, it's not embedded per se. The knowledge about this table is embedded into the engine, right? How do I put that? Let's have a look at the contents of impact sounds table. That's like known to the engine. That's used in the engine. That's used. That. I mean, what does S mean here? That is used. Table. Okay, so let's have a look at the contents of impact sounds table. That is used in the engine. I guess so. That is used in the engine. To demonstrate, let's have a look at the contents of impact sounds table that's used in the engine. Hash table plist, get hash impact sounds, blah 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 blah. So we got that. Since we use index column values as keys in the resulting hash table, it should be obvious that the index column values should be unique, as it always is in relational databases. So then goes the source of build data table. Alright, so finally we have a couple of accessors for the table data. They are not accessors per se, rather the getters, since the table data is read-only once it is loaded. So the first one, table value ref, just accesses the tables, the data tables hash table described above. It takes table designator argument as a keyword and plist of predicates which relate to index columns. It can return specified default value instead of nil when the column is not found. And it can return only a single column value instead of full plist when supplied with column keyword argument. Okay, so the important detail of the contract for this function is that supplied predicates plist should be alphabetically sorted by the names of the columns, since this is how they're stored in the hash tables we've discussed above. If we change the order, the hash value of the list would change, and this function wouldn't be able to find the requested row. To alleviate that, there is a star version of this function, table value ref star, that does the predicates list sorting at the cost of slight performance penalty. And yeah, that's that for this file. So yeah, let's commit all of the stuff that I've changed. So this hash table, and then this bit, just a JSON, and then something here I can't really see, and I can't properly toggle wrap lines. Can I though? Like alt-x, truncate lines? Toggle truncate lines. Oh, yeah, that worked. Okay, so let's lists of rows. Yeah, okay. Stage, and yeah, I think that would be it. So edit data tables docs, I guess. So the tangled file is correct, right? Yeah, it is correct. Okay, so let's commit that then. Staged. So edit data tables .lisp docs. Dun, 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 dun. All right, let's push it. Hello? Yeah, okay. So the next step would be, yeah, and the syntax highlighting here is still broken, which is incredibly weird. Okay, so yeah, the next step would be this CastleDB format support. And yeah, in this I would also have to document the priority I've had recently implemented. So yeah, I would move to that later. I guess that would be it for today's stream. Yeah, so thank you very much for watching. If you want more, we'll get back next Saturday. And if you speak Russian, return at Tuesday, because at Tuesday there would be the Russian stream the same time. So yeah, that's it. Thank you very much for watching. Take care and goodbye.